let's see today how to draw the stick diagram for the MOS circuits. So, stick diagram for MOS circuit. Right. So we know that we have two kind of MOS, that is the NMOS and the PMOS. And if we take the combination of both, you will get the CMOS. Okay, so whatever the circuit you see, that will consist of either the NMOS or the PMOS, or if you have to take both the NMOS and PMOS, then the transistor can be formed, that is known as the CMOS. Okay, so before I go for the stick diagram, let us first see how the NMOS, PMOS and CMOS can be act as an inverter. Right. So if I talk about NMOS, it is a NMOS inverter, PMOS inverter, CMOS, that can also be say a CMOS inverter. So as it is, these all act as an inverter. So let us see how they act as an inverter. So first let us draw the NMOS. So NMOS symbolic representation. The VDD on one side and the ground on another side, and the output is taken here. Right. Similarly, for PMOS, the output is taken from here. Okay, so now let us see first the difference between the NMOS and the PMOS representation for the inverter. So the difference what you observe here is the difference of the bubble that is attached to the gate, and the output in case of NMOS inverter is taken from the VDD, and the output is taken from the ground in case of the PMOS. Right. So now let us see how it works as an inverter. Right. So for inverter we know that if we apply 0 you will get 1, if you apply 1 you will get 0. So this is the truth table that we have to implement using the PMOS and the NMOS. 0 means low voltage, 1 means high voltage, or you can say another way, 0 means 0 volt and 1 means 5 volt. Right. So let us take, I apply here 0. Okay, so if I apply here a 0, this NMOS is off condition. This will be in off condition. If you apply 0 to the gate, this NMOS is off. So if it is off, that VDD is directly available here. The VDD is directly available at the output. So now the output is equal to 1. Right. So if in this case I mark here input on one side and output on another side, and the position of the transistor, let us suppose this transistor is Q, represented by Q1, this is let us suppose represented by Q2. So if my input is 0, the transistor Q1 is off. Now as the VDD is directly connected to output, so you will get output is equal to 1. Right, this is the one step. Second, if I apply input as 1, the transistor will on. The transistor will on. Now if the transistor on, this VDD directly get the path to the ground. So what you will get at this output now, you will get the output 0, because the VDD get the path to the ground. So the supply is directly goes to ground and will get 0 at the output. Right. So if you take this two condition, if I apply 0 you will get 1, if I apply 1 you will get 0. So that means it will act as an inverter. Similarly, on the P side, again you will take input Q2 position and the output. Q2 represent the transistor, whether it is on or off. The output, now here the output is taken from the ground. Now the first condition, let us take, you apply input as 0. Okay. Now due to this bubble, this means this is active low. So if I apply 0, the transistor is on. Okay. So the transistor is on. Now if the transistor is on, the VDD pass through this transistor and it is connected, it is taken the path to the output, as the output is taken from here. So this VDD take the path from the transistor and appear at the output. So the output will become 1. Now if I apply input as 1, now as it is active low transistor, so it will be off on the high voltage. So the transistor is off and the VDD will be blocked, right? This transistor is off, the VDD does not get a path to flow from the transistor. So what you will get here, output, as it is directly connected to the ground, so output is at same potential as the ground, so ground is 0 potential, so I will get 0 at the output. As the transistor is off, so I will get 0 at the output. So again look at the status. If I apply 0, you will get 1. If I apply 1, the output is 0. So in this way, the PMOS will act as a input, right? The third one, that is CMOS. So CMOS is very useful than the NMOS and the PMOS, as it gives a very high speed operation. So wherever you need a high speed operation in the application, you use the CMOS rather than the NMOS or PMOS. So in almost all the applications nowadays, the CMOS is very useful. So due to its high speed operation, right? So how to form a CMOS inverter? So CMOS is a combination of PMOS and NMOS. That means it requires 2 transistors, one PMOS and one NMOS. So how it is connected in a circuit? The upper transistor is a CMOS, is a PMOS, and the lower one is your NMOS. Upper is VDD, this is ground. The gate of the 2 transistors are short together and taken one terminal at the output. So input is applied here. This is basically the gate terminal of the gate of 2 transistors are connected together and is commonly taken for the input. The output is taken. The output is taken here. The output is taken here. The output is taken here, right? So for PMOS, the source is here, drain is here. Always remember, for the PMOS, source is upper and drain is lower. For the NMOS, drain is upper and the source is lower. So drain of both the transistors are connected together and commonly taken away for the output, right? So this is the circuitry for the CMOS. So this basically, this is a by default circuit for the CMOS and it will act as a inverter. Now we will see how this circuit can be act as an inverter. So we similarly proceed as we did earlier for NMOS and PMOS. Let us suppose I apply the input as 0, right? So we make the truth table as input on this side. Then let us take this transistor as Q1 and this transistor as Q2. So Q1 and Q2 and the output, right? So we will analyze from this table. First of all, I apply the input as 0. So let us suppose input is 0. Now this PMOS, so let us, this Q1 is a PMOS transistor. This is your NMOS. Now if I apply 0, as the two gate is short, so same voltage is appear on both the gates, right? So 0 is appear here, 0 is appear here. Now we know that this PMOS is active low, so if 0 is at the gate, this transistor becomes on, and the NMOS becomes off, right? So this is Q1 is on and Q2 is off. Now this is off, that means this portion is cut off, right? This transistor is on, so the VDD get the path to the through the transistor Q1, and the voltage VDD is appear at the output through the transistor Q1. So the output becomes 1. The path Q2 is blocked as this transistor is off. The Q1 is on, so VDD appear at the output terminal through the transistor Q1, right? Similarly, now if I apply 1 here, the 1 will appear at both the gate terminals. So now the situation reverse. The transistor Q1 is now off and the Q2 is on, right? This becomes off and this becomes on. Now the path of the VDD is blocked by Q1 because Q1 is off here. So now the output is, as the output is connected to ground, so what appear at the output is the ground potential. So ground potential is 0, so I will get 0 at the output, right? So again you observe, for 0 you get 1, for 1 you get 0. So in this way you will get CMOS as an inverter. Okay. Now let us see that how to draw the stick diagram for the CMOS circuit. Okay, so let us take the circuit as it is. Okay, let us take the CMOS inverter here. CMOS inverter here. VDD, ground, output is here. VDD. Okay, so this is CMOS inverter. Now let us draw the stick diagram for this. For stick diagram, we require the circuit, and from that circuit you will draw the stick diagram. So we know these rules for drawing the stick diagram. So one by one we also see the rule and let us draw. So the supply lines are taken. So this is your VDD. So VDD is shown with the blue color. Ground, this is also shown with the blue color. These two lines should be blue. Right now we have the PMOS here and NMOS here. So this is P diffusion. We have to show the P diffusion here and N diffusion for the NMOS. So for P diffusion we know that the color is brown. So we take this as a brown color. For NMOS diffusion, for PMOS diffusion, and this line is taken for is green color, is taken of green color for the NMOS diffusion. Okay, so side by side you will see the rules for drawing the stick diagram. Mainly we have to show the pattern of the circuit, right? So circuit diagram is drawn with the symbolic representation, and the pattern of that, or you simply the layout of this circuitry, that is shown by the stick diagram, right? We will not take any symbolic representation in the stick diagram, only we take the color combination and the finger and the lines. So due to these lines, the name given as a stick, right? So all the circuit is represented by the lines, so that's why the name given as a stick diagram, right? The only thing we taken into consideration, the coloring that are taken for each line, right? So we have different colors for the different diffusions, supply lines for taking the connections, right? So for supply lines, it is taken with a blue line. For P diffusion, you take a brown line, and for N diffusion, you take a green line, right? Now, how to draw the transistor? We also discussed earlier that the whenever there is a crossing, that is polysilicon crosses the diffusion line, there will be a transistor, right? So for polysilicon, we take, this is the polysilicon line, and this line is of color red, right? Now here there is a crossing, polysilicon cross the diffusion line, so that means here is a transistor. And which transistor? That is PMOS, because this vertical line is your brown and horizontal crossing is of red. So polysilicon cross the brown line, red line cross the blue line, that means a PMOS transistor. On the lower side, the red line crosses the green line, that means here the transistor is NMOS, right? Now the input, now from this we take the input. So I have to mark here the connection. Either you can mark with a round circle or you can take a cross. So I have taken here a cross to show that there is a connection, and this connection is taken for the input, and this color should be black. Okay, the connection line is a black line. This is the brown line, this is the green line, and the crossing is of red line. So we have marked the two transistor PMOS and the NMOS here, and the supply lines. Now what remains? We have to take the output. Now for the output, again we have to take one connection here, one connection here, and with the black line I have taken the output. So this line is a black line. So this is the simple stick diagram for the CMOS inverter. The only thing is you have to take care of the color combinations that are taken for each parameter or each symbol or line, right? So this is where to draw the stick diagram. Now let us see another example for the NAND gate and the NOR gate, right? So let us design a NAND gate using the CMOS, okay, CMOS NAND, and draw the stick diagram for that, right? So let us see how to draw the stick diagram for CMOS NAND circuit. Okay, so for that, what we have to draw, the equation is, let us take the two input A and B. So the equation is A plus B bar, that is the NAND operation, right? Now the circuit diagram for this using the CMOS, we have to take two sets of PMOS and NMOS. So PMOS here are connected in series. So this is the VDD, this is input A, and this is input B. On the lower side, we take the NMOS transistors and they are connected to ground. This is, let us suppose, A and this is B. So basically they are connected together, but here for simplicity I write here separately A and B, means these two are connected together, these two are connected together, right? So this is the simple circuitry for the CMOS NAND. Okay, always remember that wherever the positive sign is there, the PMOS are connected in series and the NMOS are connected in parallel, right? If it is for the NOR, that is A dot B bar, right? So then the PMOS are connected in parallel and the NMOS are connected in series. That is the only difference. Always remember that. This is a simple way to draw the circuit. So here we have taken the CMOS NAND. Okay. Now these two are the PMOS and these two are the NMOS. NMOS are connected in parallel, CMOS are connected in series. Now you draw the stick diagram. Okay. So basic rule is the same. Stick diagram, take the two wires, blue wires, one is VDD and another is ground. Okay. Now we have two kind of diffusion. So take two lines, one for the PMOS or P diffusion, and another for the N diffusion. Okay, so basically this is your brown line and this is your green line, right? For P diffusion it should be green, so let us better to mark it with a color. This is the brown color for the P diffusion, and this line is a green line for the N diffusion, right? So this line is blue for VDD and ground. These lines are made up of blue color. Now there are two transistors, so mark that lines here, two lines, one for A, okay, mark the cross here, and one for B. These are the two inputs, right? A and B, these are the two input, and these lines are from the transistor. So we have 1, 2, 3, 4 transistors. So this crossing 1, 2, 3, 4, 4 crossing. So we have 4 transistors, right? 2 crossings here with the green. These lines are the red lines. Okay, these are the red lines. These two are red lines. So these polysilicon crosses the diffusion line. So the transistors are formed. So we have crossed here 4 times. So we have 4 transistors, 1, 2, 3 and 4, right? So let us take, this is Q1, this is Q2, this is Q3, this is Q4. So basically you can take Q1, Q2, Q3, Q4, right? So this red crosses brown, so PMOS on the upper side. So this red crosses green, so 2 NMOS are on the lower side. Right now, the another rule, we have to mark here the source and drain for the transistor. So what is the rule for drawing that? We have discussed in the last circuit. So for the PMOS, source is on the upper side, drain is on the lower side. Source is on the upper side, drain on the lower side. Here for the NMOS, drain on the upper side, source on the lower side, drain on the upper side, source on the lower side, right? So here you will see where we have to take this drain of A is connected with source of B, right? This is A and this is B. So how we will read it? The drain of A is connected to source of B. So this is A and this is B. So we will take drain here and source here, right? On this side. So drain is connected with source. Drain of A is connected with source of B, and source on this side and drain on this side, right? Okay. Now on the lower side, two drain of A and B are short together. So that means on this side you will take drain and on this side you will take drain. Drain of two are connected together and they are connected with the drain of B. The drain of B is this one, right? So these two are connected with the drain of B. The two drain of NMOS are short together and they are connected with the drain of B. Drain of B. This connection, right? Similarly, the source of the two source is here, right? So if drain is here, the source on the other side. Now this source of both are short together and they are connected to ground. So that means this is connected to ground, this is connected to ground. The source of both the transistors, source of both the NMOS transistors connected to ground, are connected to ground. For each connection, you have to show a cross. Similarly, the source of A is this. Source of A is connected with the VDD. So, source of A is connected with VDD, right? So, the supply connection is here. All the supply lines are connected with black, right? Always remember, all the supplies are connected with the black lines. So, supply lines are black, sorry, connection lines are black, supply lines are blue, polysilicon is red, P diffusion is brown, N diffusion is green, right? Now input is connected here, A and B, and now the only remaining is the output. So output is here. Output is here. So drain and drain. So drain of the NMOS are connected with the drain of the B, and from this you will take the out. You will take the out, right? So this is a simple way to draw the stick diagram. Now you will observe the difference between the circuit diagram and the stick diagram. The circuit diagram is the symbolic representation of the components connected with the wires to form a complete circuit. Now here all the diagram is consist of the lines because it is a stick diagram, so all are shown with the sticks and the color pattern to represent the particular transistors or the components, right? So this is basically a layout pattern that is to be transferred on the wafer so that the IC can be formed, right? So this is all about how the stick diagram can be formed from any circuit. So in this way you can take any circuit and you can convert it into the, or you can redraw the circuit diagram with the stick diagram. The basic rules remain the same. Thank you.